After more than, I think, 70 videos of differentiation, we have finally arrived at the realm of integration. So we're going to start looking at new branch of calculus, starting this episode, starting this video, which I find very exciting. Now, what is integration? There's two types of integration. There's indefinite integration, which is what this video is going to introduce you to, and there's definite integration. And indefinite integration looks something like this: 2x dx with this squiggly s sign, and we have some function within, and we put dx. And definite integration has lower bound and upper bound with the same thing. And you may be asking, what's indefinite and what's definite, and why do the signs look so similar? How are they related? And as we are about to find out in future videos, fundamental theorem of calculus, arguably the most important theorem in all of calculus that links differentiation and integration together, is going to show you why we use the similar sign for indefinite and definite integration, which are used to find seemingly different things. But for today, let's focus on indefinite integration. Indefinite integration. And indefinite integration is exactly the same thing as finding antiderivative. So anti-differentiation. So indefinite integration and anti-differentiation are the same thing. Now, what is anti-differentiation? We know differentiation. Let's say I give you a function, f of x is equal to x squared. What is f prime of x? That's just differentiating f of x. F prime of x, I hope you know by now, is 2x. So we know that's differentiation. Just taking derivative. Now, let's say someone comes up to you and write down a squiggly s and put 2x inside it and put dx, and they ask you what this is. Now, don't be confused. Don't freak out. This is nothing more than asking you, what function do we have to differentiate? To get the thing inside, to get 2x. That's all this is asking. This squiggly s 2x ds is telling you what function that we differentiate, and we get 2x. Now, you may say x squared, and you'd be correct. Yes, if we differentiate x squared, we do get 2x. But consider this. Let's say f of x is x squared plus 1. Now, what is f prime of x? F prime of x is still 2x. How about f of x equals to x squared plus 200? F prime of x is 2x. F of x is x squared plus 0.1. F prime of x is 2x once again. So it's not just x squared, but it's x squared plus c, where c is some constant. We also call this constant of integration. So we know integral of 2x plus dx is x squared plus c, and please realize the indefinite integral of 2x plus 2x dx is giving you a family of function. That's a family of functions. In this case, it's the x squared with vertical shifts. You got the parabola x squared going. You also have x squared plus 1, x squared plus 2, x squared minus 1, and everything in between. So x squared plus c, the result we got from indefinite integration, is not a specific one function, but a family of function. That is very important. And that's all indefinite integration is. Obviously, it's going to get more complex, and we're going to dive into how to indefinitely integrate more complex functions in the upcoming videos.